I hope you must have enjoyed our last discussion on artificial intelligence. In that particular session, we talked about why AI, where AI, what AI, and how AI. That was the point of discussion. And I hope you must have explored the technology in the initial beginning so that you are very comfortable taking it forward. Good. So let me do one thing. Let me today talk about one topic which is almost near to what we discussed last time. And today's topic is data science. And in today's session, what we are going to do, we are going to talk about again those four quadrants. Why data science, where data science, what data science, and how data science. So that will be a broad level of discussion today. And I would request you to use the chat window wherever you feel like asking any question or sharing your thoughts so that we all are on the same page. So when we talk about data science, very important thing altogether. The keyword in data science is not data, it is science. It is very important for us to understand how the data is engineered to get something out of it. So when we talk about something out of it, it is primarily one particular step where we convert raw data into information, and that information is converted into knowledge, and that knowledge is converted into wisdom. So four steps. Let me repeat. Raw data converted into information converted into knowledge, and knowledge converted into wisdom. So that is how those four steps are very important and very critical for the businesses to draw a leverage out of it. When we call benefit of doing these four steps for an organization, there are many. During the next 60 to 75 minutes, we are going to talk about those benefits. And when we talk about why we are doing this, what is the importance of data science, McKinsey, you might have heard of the name. This is a global consulting firm. It is saying that there is a shortage of data scientists who can make sure that you convert the raw data into wisdom for your benefit. That is how it is very important for us to understand the nitty-gritties of data science. And when we talk about data science, it again constitute four quadrants. First is stats and probability. That's what we talked about in AI also. Now you can start correlating what we are talking about, because this is very important for us to draw a very thin line between these two things, these two concepts, so that we are very much aware of what we are talking about. Second block, machine learning. Third block, computer science. Fourth block, mathematics. So that is how it is structured altogether. And when we talk about data science, it is primarily science what we are going to talk about. So what next? Just spend 1 minute on this slide. You will get to understand what is happening in our world in 60 seconds. When we talk about 60 seconds, there are 3 million items shared on Facebook in 60 seconds. There are 50 billion emails sent across. There are 430,000 tweets sent on Twitter. There are 27 lakh videos viewed on YouTube, and so on. List is very, very long. So that is the reason I'm requesting you to spend a minute. This particular thing will give you a flavor of what is happening in 60 seconds over internet. So this is humongous data altogether. When you talk about various things, you talk about Gmail, you talk about Netflix, you talk about Amazon, you talk about anything whatsoever is available on internet. And this slide depicts that how things are moving very quickly as far as volumetric data is concerned. Let me refine the term, volumetric digital data. Now we talked about digital data per se. So in that particular scenario, a lot of digital data is happening because this is a digital world. And when it is a digital world, we must understand that there are different types of digital data. So when we talk about different types of digital data, what are these types? So these three types of digital data is available. When you talk about digital data, it is a structured data, it is unstructured data, and there is semi-structured data. So three different types of data. So when you talk about three different types of data, structured data, you will slowly understand when you will go into your second semester, third semester, and all that. You will be learning databases. You will be learning database management system, DBMS. And that is how you will get to know that whenever you are feeding some data or you are capturing some data, so there is a template available. Now, what is template? Template is just one particular table which will help you to capture particular data points on a particular scale. Let us say you go to your college, you have joined Chitkara University, and then what will happen on day one? You are asked to fill your personal information form, and the HR person or the faculty member will give you one particular blank form. That blank form is common for all the people. That is where the templates come. So that is a template given to you. And you fill your data, your name, your age, your date of birth, your college, your +2 marks, your 10th marks, and then your hobbies, whatsoever you have learned, blah, 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 blah. In that particular scenario, that is one form of capturing data which is having a structure. And that structure is for everybody, whomsoever is using that template. That is where structured data comes into picture. You might have seen Microsoft Excel. In Microsoft Excel, there's a table defined and you go on entering the data. You cannot enter the data between the cells. So one cell, the next cell, the next cell. It may be horizontal, it may be vertical. That is where data is organized in the form of rows and columns. And that is what it's known as schema. Schema is one word you'll be learning when you will be exploring DBMS. That is nothing but a template. Second type of data, that is primarily unstructured data. Unstructured data is, let us say we are talking. I'm speaking, you are listening, you are noting down something, and then you are also speaking. In that particular scenario, what will happen? There's no template we are following. Only thing is, I'm speaking in English and you are listening in English. That is where there's no structure altogether. And that particular data, if it is captured, it is unstructured in nature. There's no structure, there's no template, there's no schema altogether. So that is a beautiful difference between structured data and unstructured data, that in structured data, you do have a template available. You do have a schema available. And unstructured data, there's no schema, there's no template. Like satellite images, you get a lot of messages on social media, like Twitter message. A lot of tweets are happening around, or scientific data. That is what is categorized as unstructured data. Third type, between these two, structured and unstructured, that is semi-structured. And when you talk about semi-structured, it is primarily one way of using a structure, but actually on a broader level, structure is missing. There's no single data model available or no single data structure available, but it is semi-structured. Like you might have seen, you might have written HTML files. You might have built a website for you. What happens? There is a starting tag, there is body tag, and there is end tag. That is how you write any HTML file. Or when you talk about an email, just see, email has a structure. You write to, from, subject, and then text. That text part is unstructured in nature, but it has some structure that yes, here you need to fill email ID to which you want to send an email, from, and then subject. So that is what the difference is between structured data, unstructured data, and semi-structured data. Whenever you are aspiring to become a data scientist, you need to handle these three types of data. If you are very comfortable handling, I think you are through as far as your point is concerned, learning curve is concerned. So Sahil asking one question, what is RDBMS? RDBMS is Relational Database Management System. Relational, one word is relational. Relational is, Sahil, that it is primarily linking a lot of tables all together. So there are relations you need to define. And there are structures available, there are templates available, there are schemas available. In third semester, you are going to learn that. So Satvik says, can we say RDBMS is kind of SQL? SQL is structured query language, Satvik. This is SQL, structured query language. And RDBMS is relational database management system. So one is language, one is system. And when you are building a system, you need a language. So that is how you can correlate. Okay. Sabrat is asking, is data structure and algorithm and structured data same? There's a linkage, Subrat. There's a linkage. When you are talking about data structures are basically structures, templates. And when you talk about structured data, definitely data will be filled in a structure. Or other way around, data will be captured in a structured way if it is a structured data. So that is how you can correlate. Okay. Time to time, I'll come to your questions and answer. Keep on asking those questions so that we are very comfortable. Then, when we are clear about structured data, unstructured data, and semi-structured data, it is very, very important for us to understand how much data is available in this world and what type of data is available in this world. Gartner says that whatsoever digital data is available around us is 80% of that is unstructured in nature. Huge number, huge number. And when you talk about data, it is everywhere. So few data points for your very quick reference. Spend 30 seconds to go through this particular slide. 23,15,000 search queries every second on Google. 1 trillion photos will be taken and billion will be taken, billion will be shared online. 50 billion smart devices will be connected. Huge data. And then 4.4 zettabytes today to grow to around 44 zettabytes to around 44 trillion gigabytes. This is the amount of data we are going to handle. So be prepared. You are already in 2022. So the challenge will be not the data, but how to extract information, step number 1. Then convert that information into knowledge, step number 2. Convert that knowledge into wisdom, which is beneficial for the business. So that is where you are going to make your career. That is where we are trying to learn this particular field as far as our career options are concerned. Make sense? Because at this moment of time, only 0.5% of all the data whatsoever is available, we are talking about zettabytes, is analyzed and used. Rest of the data is still unused. Very, very important point altogether. That is where the future of data scientist is very, very good. So that is where the potential lies. Okay, let me put 4 pictures in front of you. And I would request you to answer the question written at the top. What is common among? There are 4 things. Let me revisit those 4 photos. First is Barack Obama winning 2012 US presidential elections. Why I have taken this particular thing, I'll tell you. Then 2014, Germany winning FIFA World Cup. Some of the students in this group must be following soccer. And third one is Macy's. If few of you have visited the US, you must have seen Macy's stores across various locations. And then 2014 Lok Sabha elections, Narendra Modi winning a lot of seats. And what is common among those things? Okay. So lot of questions, lot of answers are floating. Sahil says campaigning on social media. Subrat says perseverance and dedication. Satvik fan following. Arshia, they are winners. Gagan, data that helps them winning. Gagan, I'll go by your answer. Avishi, success is common. Rahul, thumbs up. Data is the difference. Winners who have methodically aligned data to their advantage. So there's a homework for you. Just note down these 4 things. Add a plus data science in Google query and just see if you get 4 documents. Barack Obama winning 2012 elections plus data science. Germany winning FIFA World Cup plus data science. Macy's plus data science. NDA winning 282 seats plus data science. So you will get 4 different case studies. I would request all of you to go through those case studies after this session. And you will love to go through those documents because Those documents will give you a hint of what data scientists can do in this world. Very, very important. Very, very important. So that is how. Now, when we talk about methodical alignment of data, what is it? So we need to understand what is the meaning of methodical alignment. So these are few answers to the question that what is methodical alignment. When we talk about methodical alignment, it is primarily objective observation, evidence extraction, benchmarking, reasoning for general rules, pattern finding, critical analysis, verification and testing. That is how you are going to move. Very, very important point for a data scientist to understand these 7 bullets. Because if you are a data scientist, you will be working on these 7 bullets altogether. Because you need to methodical align the data. Okay. So how important it is to methodically align the data. Some marketing figures, 1.2 quadrillion US dollars market is primarily based upon data science. And if we can get 0.0001% of this market, will be in billions. That is where a lot of companies are moving into data analytics, data engineering, data science, and all that. Because there's a huge chunk of data, you need to apply certain algorithms to extract information, then convert that information into knowledge, then knowledge into wisdom. That is how the whole circle acts. And it is very, very important for us to understand the potential of this market. Let me give you a few examples. When we talk about few examples, you might have seen whenever you are in a store, you might have seen that when you are going to make the payment, we call it POS, point of sale, where you make the payment. You give your credit card or debit card, they make a bill and grocery or other things. There are a lot of things lying on that table. Whenever next time you visit any mall or store, just observe what is lying on the POS, point of sale, where billing is being done. And you will get to understand, just stand there for 10-15 minutes and observe what customers are doing. Whenever they are done with their basket, they will put over there and pick 1 or 2 things from those things. Okay, chalo chocolate bhi le lete hain, chalo lollipop bhi le lete hain, or something. So that is what it is called, market basket analysis. How likely it is that people who purchase pizza base are also likely to purchase pizza cheese. This is very, very important for us to understand. So that is how market behaves. In a couple of years' time, you will be going to join various companies, or even you're going to start your own venture, your own startup. You need to understand what you are going to do when it comes to market analysis, because ultimately all drill down to money. How many dollars you make out of your business. Second, have you ever seen somebody predicting your preferences? Whenever you visit any restaurant, you pick one dish, and then what happens? You take one example of, let us say, Domino's. You might have observed that Domino, if you are a regular pizza eater, you will keep on getting messages based upon the purchases you have done in the past. That there's a scheme, there's a offer and all that. So that is where predicting user preferences is a big, huge market altogether. Similarly, can you predict the price of a household? That okay, this is a flat or this is one house. What is the cost of this? Can you predict? That is where data scientists will come into picture. There are many factors which data scientists will ask you. How many number of rooms are there? What is the area, direction, east or west or south or something like that? Whether that whether that is an apartment or independent house, or whether it is downtown or in suburbs. So a lot of factors are there if you want to predict the price of a house. Similarly, there are many companies who are predicting the trends in the stock market, how it will work. This is a huge market altogether. Similarly, you might have seen, you keep on accessing, let us say, Times of India on your mobile phone. You will get to understand that if you browse through that particular website for 3 to 4 to 5 times, sixth time, the news which are being shown to you are based upon your interest. Just observe. It is nothing but data scientist is working in the background, just observing whatsoever you are browsing. This is the beauty of data science. Similarly, you might have seen this. Whenever you visit Amazon or Flipkart, it gives you options. Frequently bought together, customers who bought this, also bought this. What other items do customers buy after viewing this? So that is how things move. But how it is moving? Because in background, one data scientist is observing you, observing your moves, and accordingly suggesting you something. Very, very important. Similarly, same thing happens on LinkedIn or Twitter or Facebook. So what else? We can probe from the data. Lot of meaningful information. What that particular information. So these are the questions a data scientist generally answer. I would request you to spend a minute in just reading out those questions. In the meantime, let me browse through the chat window. Yes, Sal, you are right. It is because of many searches and social giants just recommend what's popular. Answer is yes. This is where they make money. And making money is a big business nowadays. And yes, you can talk about recommendations must be done through AI, but initial beginning, it is data science only. Make sense? So these are the questions a data scientist answers. What kind of problem needs to be solved? Is it possible to identify the quality of data? Is the data ready for analysis, or we need to do transformations? What are the potential sources of data? What is the size of data? Is there anything missing? Is there any correlation between different features? Is there any pattern available? Is it descriptive, predictive, or prescriptive analysis? Do I need to optimize, or do I need to orient and align data? So these are few questions a data scientist answers. And then when it comes to data science, it is all about handling these questions. That is where the role of a data scientist comes. So that now I would request you to just recall our discussion for the last 20-30 minutes and see what data scientists can do for a business. It is very, very important for us to understand. So what is data science? So there are two words, data and science. Let us try to answer these two words. So when you talk about data, it is primarily facts and statistics collected together for reference or analysis. This is the Oxford Dictionary definition of data. And when you talk about science, according to Science Council, science is a pursuit and application of knowledge. Mind, application of knowledge and understanding of natural and social world following a systematic methodology based on evidence. Just see how critical and important it is to understand and correlate data with science. So data is basically facts and figures collected together for reference or analysis. But science is application of knowledge, whatsoever you have learned, in a systematic, methodical manner. That is how data science is all about. So now let us try to define data science. I've taken this definition from Wikipedia. Data science is an interdisciplinary field about processes and systems to extract knowledge or insight from data in various forms. Just observe, in various forms. Forms are structured or unstructured, maybe semi-structured, which is a continuation of some of the data analysis fields such as statistics, data mining, and analysis. Second definition and third definition. All three definitions I have taken from internet. So, one is NIST. Homework for you. Whatsoever I am telling you, just browse through that particular thing after the session. NIST is one particular place where you will find global definitions of technology, frameworks, standards, etc. That is National Institute of Standards and Technology, based out of the US. A very, very reference point where you will get precise definitions. Because if I go through the NIST definition, it says that data science is an empirical synthesis of actionable knowledge from raw data through the complete data life cycle process. इसको समझने में आपको 1 मिनट लगेगा, इसको पूरी की पूरी डेफिनेशन को समझने में. You are trying to work on actionable knowledge. When you talk about actionable knowledge, basically knowledge, we talked about raw data and followed a life cycle. That life cycle was raw data to information, information to knowledge. That is what it is talking about, actionable knowledge. So you can start correlating what we are talking about so that you get to understand that yes, that is what you need to do. Okay, pretty interesting. So let us talk about certain business fields and major components of data science. When you talk about major components of data science, data will be at the center place. You need to go for probability and stats. You need to learn linear algebra. You need to learn machine learning, and you need to get the core of computer science. We talked about this thing in our previous section also. If you remember the 4 quadrants, one quadrant is different. In data science, it is linear algebra. In artificial intelligence, it was NLP. Rest of the 3 are same. So slowly and slowly, you will get to understand the thin line between these two concepts, right? So let us talk about these things. So each block one by one very quickly. So first block is probability and stats. So when we talk about this particular block, this is the simple definition of probability. We have learned probability, we have exercised probability during our 11th and 12th class. There was a complete chapter. It is a branch of mathematics that deals with calculating the likelihood of a given event, whether it is 0 or 1. Right? So head or tail, 50-50 chances. So that is what likelihood is all about. What is statistics? It is a branch where collection, classification, analysis, and interpretation of numerical facts for drawing inferences on the basis of their quantifiable likelihood. Quantifiable likelihood is probability, and that is a base of collection, classification, analysis, and interpretation of data. Statistics, very quick example, mean median mode. You might have understood this particular thing in your 10+2. So if I mix these two definitions, probability is the study of random events, whereas statistics is the discipline of using data samples to claim something out of that. What is that particular claim? It is based upon the probability of events, likelihood. And when you mix these two things, that is where computation will come into picture. It is a tool where quantitative analysis is being processed. So a little bit of technicalities as far as probability and stats are concerned. We are not going to go into the deep, but we are just touching the concepts. Then comes linear algebra. So when you talk about linear algebra, as per the American Heritage Science Dictionary, linear algebra is defined as the branch of mathematics that deals with the theory of systems of linear equations, matrices, vector spaces, and linear transformations. कुछ चीजें आपने 10+2 में पढ़ी हुई हैं। आपने मैट्रिसेस पढ़ी हुई है, आपने लीनियर इक्वेशंस पढ़ी हुई है, आपने वेक्टर्स पढ़े हुए हैं, आपने लीनियर ट्रांसफॉर्मेशंस पढ़ी हुई है। बट उन चारों को जब मिलाते हैं, दैट इज वेयर लीनियर अलजेब्रा कम्स इनटू पिक्चर। वो कैसे मिलाएंगे वो देखते हैं। सो व्हाटसएवर कॉम्प्लेक्स साइंस प्रॉब्लम इज, linear algebra converts that problem into a vector and matrices and then solve that particular thing using linear models. So this is in nutshell linear algebra is all about. Let me revisit the definition again. You do have any complex science problem, you convert that problem into a vector, problem of vectors and matrices. How to solve vectors we know, how to solve matrices we know, using linear models. That is how linear algebra does it, the huge work of converting or solving any given complex science problem. What can be that particular problem? It may be graphical transformation, it may be face morphing, it may be object detection, it may be audio and image compressing, it may be edge detection, it may be blurring, it may be signal processing. Lot of complex science problems are there which can be solved using linear algebra. And when we talk about linear algebra, basically there's a business problem, and appropriate statistic computation technique, just like linear algebra, can be used to solve that problem. Example, very quick example. On your left hand side, there is an iterative method. Let us say number of columns are 10,000, number of rows are 1,000, and you need to get a sum of it and then square it. So you need to go for complete sum of the matrix, square it out, and then take the square root. On your left hand side, when iterative method is being used, so this is where I have taken this particular example by executing the code. In first semester, you have executed the code, and you have found what is the time period taken to execute the code. Left hand side, it was 15 seconds. But when you do using linear algebra, see the time difference. It is approximately 0.038 seconds. Only thing is, I have changed the code by using linear algebra instructions. Linear algebra function, which is denoted by normal. So that is one particular difference of code execution when you go for simple iterative method versus linear algebra. So that is what Frobenius norm of a matrix is being calculated. Let us take another example. Message transmission. Let us say you need to transmit one message, prepare to negotiate. So this is what one method you need to transmit. So when you are going to transmit, so there should be a transmitter, there should be an encryptor, method should be encrypted, then it is transmitted, then it is received and decrypted. That is how we do in our modem also, modulation, demodulation. That's what we have learned in our physics. So prepare to negotiate. So alphabets, their names are their alphabet sequence numbers are written, converted into a matrix. That is what the definition of linear algebra was. Just recall that any complex problem is converted into a linear model. It may be a vector, it may be a matrices. That is what it has done in this particular example. Step 3, encoding matrix is being embedded, multiplied, and got one particular message vector finally at the bottom. At the receiving end, inverse of that encoding matrix is being used. Just see. So this was -3, -3, -4, 0, 1, 1, 4, 3, 4 was the encoding matrix. Just calculate its inverse. So this will be the inverse matrix, and use that inverse matrix to get the signal back. That is how linear algebra works. Simple. You have done it already in your +2. So nothing new over here. Only thing is application is new. You have not learned about how these matrices and vectors are going to help you in solving a problem. Here, when you are learning data science under linear algebra, you will be implementing those concepts in various applications. Second example, Kirchhoff's law we have applied to solve such problems in our +2. Converted into linear equations, converted into matrix, and solving it. So this is what we have done already, but this is the application of the concept. Whatsoever we have learned in +2. Similarly, this is social map, social networking map. So there is visitor 1, 2, 3, 4, 5. 5 visitors are there, and how they are linked. So there is a directed graph converted into a matrix. Wherever relation is there, we are denoting it as 1. Wherever relation is not there, denoting it with 0, converting it to a adjacency matrix and solving it. So that is where a beautiful concept by the name linear algebra is there, which will help us to solve any given complex problem. Third block, machine learning. When you talk about machine learning, yes, we touched upon machine learning in our last discussion also. Let me give you another flavor of it. Machine has beaten man in chess. So there were two matches held in 1996 and 1997 between Gary Kasparov and Blue Deep. Blue Deep is a program written by IBM. And this was a scorecard. In 1996, the score was Kasparov 4, Deep Blue 2. But taking 1 year to train itself, the score in 1997 was Deep Blue 3.5, Kasparov 2.5. So that is what machine has beaten a champion. So that is where machine learning is being used wherever we want to analyze some data, and wherever we want to analyze some data and human expertise is missing. Like, let me take one example. Like, we need to navigate to Mars and we don't know how to do that. So we can make one machine learn it and do it for us. That is where machine learning is very, very handy when there is a huge cost associated with human beings. And we are not experts in doing that, where we can go for a machine to do it for us. Let us very quickly discuss few examples. This is how machine helps us to read different handwritings. A is written, B is written, C is written, different forms, but machine is capable of recognizing them digitally. That is the beauty of machine learning. Second, face recognition. You might have seen various systems available nowadays in various offices that yes, attendance is being taken by face recognizing machine. That is how you train that machine, and then you will find one person. So on the left hand side, you have told the machine that these are the 8 people who are going to come to my office, and then float some 20 images and ask the machine to find Sophie, and it will do that for me. So indeed, very, very interesting. So Sahil asking, even for normal people, we can search faces on Google Lens. Answer is yes, Google Lens is nothing but one particular application of machine learning. Right, Sahil? Okay. So let us try to understand machine learning a bit more. So when you talk about machine learning, so it is a branch of artificial intelligence. Now mind the definition. It is a branch of artificial intelligence in which a computer generates rules underlying or based on raw data that has been fed into it. This is one very, very simple definition. And another definition, I would love to read out the last definition. And whomsoever is a mathematician in the class will appreciate this. Let me read out. A computer program is set to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. मजा आ गया? कितनों को समझ आई है? Good. So that is where it is called machine learning. Friends, very, very beautiful things are in store when you talk about machine learning, when you start exploring machine learning. Because if you understand the last definition, it is the gist of complete machine learning. So then you will be able to weave story around it. Very, very good. Okay. So this is what I would like to explain now. So these are the formal definitions. कुछ easy way में बताओ तो बात बने, कुछ समझ आए. So let us try to explore. So what are the types of learning? So let us try to talk about 4 types of learnings. 4 types of learnings. When we talk about 4 types of learning, it is supervised learning, it is unsupervised learning, it is reinforcement learning, it is semi-supervised learning. 4 types of learnings. So when we talk about 4 types of learnings, let us try to explore very quickly what it says. So supervised. Supervised means you are exposing these 6 pictures to your machine, to your algorithm. That this is apple, this is banana, this is grape, this is orange, and all that. And when this is machine is aware of that, then comes you throw another set of pictures and ask computer to recognize whether it is able to do that or not. It has done certain things. Certain green ticks are there, certain red crosses are there. Means somewhere it is okay, somewhere it is wrong. So when we talk about this, see, 6 out of 8 images were categorized as correct. Means accuracy of my supervised machine learning model is 75%. That is how I'll go into the market and tell my customers that yes, I am working on 75% accuracy. When we talk about accuracy, what is the meaning of accuracy? Accuracy is one of the parameters to evaluate a given machine learning model and is defined as the ratio of correct classified data to the total number of test data. Whenever next step will be start learning the nitty-gritties or various blocks of data science. So one is whenever you are building a model, people will ask how accurate this model is, how accurate this model can go for. This is one very, very important thing. So to summarize, in the first step, we'll train the machine. In the second step, we'll expose the known data and classify it. Third step, we'll throw unknown data. So 3 steps. Whenever you are talking about supervised machine learning, so 3 steps. First step, you need to train the machine, throw data, throw unknown data. And that is how we are going to make it forward. So supervised learning categorized into 2 subheads. One is regression, one is classification. So when you talk about regression and classification, let me very quickly give you the definitions. When you classify something, right? So classify means this particular thing comes in this category or this category. So you are discrete either this way or that way, right? So classification problem will always give you discrete output this way or that way. But regression, so whenever you are talking about regression, it will throw you continuous like price. Price is not discrete. Price you say okay 10 rupees, 10.5 rupees, 11 rupees or something like. So this is a continuous thing. But let us say I'm going to expose one picture. Picture is, let us say, of glass. So I'll say, is it a mug? I'll say no. Or classify this. I'll say this is a glass. Something like that. So this is next level of supervised learning. Unsupervised learning. When you talk about unsupervised learning, you do not train the machine. You do not supervise the machine altogether. You throw it, only few labels are there. Labels means some colors. when you talk about colors, you throw the test pictures and it will say that these are red fruits, these are green fruits, these are yellow fruits, these are orange fruits, something like that. When this happens, that is how unsupervised learning, because you don't know anything about this. Some variables are available like colors, nothing more than that. Because when you recall supervised learning, it was telling you that, okay, this is the picture of banana, this is the picture of grape, this is a picture of orange, this is a picture of lychee, something like that. But here in unsupervised learning, you're only talking about very, very small variables. So where does semi-supervised learning falls into? Something of supervised, something of unsupervised, and it is a mixture. Just like semi-structured data, we do have semi-supervised learning. So examples, text processing. Certain things are known, certain things we don't know. Video indexing, certain things are known, certain things are not known. Bioinformatics, web page classification, news classification, certain things are known, certain things are not known. So that is where semi-supervised learning comes into picture. So when you talk about next level, it is reinforcement learning. When you talk about reinforcement learning, you don't know anything about this. You don't know anything, because when you talk about supervised, there was complete data available. Unsupervised, there were few parameters available. But when reinforcement learning, nothing is available. Learner is not told to do anything, but they need to discover. That is where hit and trial search will come into picture. Like let me give you one example. You are going to visit Mars. You don't know anything. You don't know anything. You send a robot which will just keep on doing hit and trial. यहाँ पे पैर रखूं, यहाँ ना रखूं, यहाँ पे jump करूं, यहाँ ना करूं, something like that. So in that particular scenario, what happens? That you need to reinforce the learning into the model. Very, very critical for us, because when you talk about the definition, it is defined not by characterizing learning methods, but characterizing a learning problem. एक problem आ गई है, उसको सीखना है, कैसे सीखेंगे? Any method that is well suited to solving that problem is considered a reinforcement learning method. थोड़ा सा ऊपर से जा रहा होगा, कोई बात नहीं, नो वरीज. अभी आपको सिर्फ इतना पता होना चाहिए कि यस, डिफरेंट टाइप ऑफ मशीन लर्निंग मॉडल्स कौन कौन से होते हैं. सुपरवाइज्ड लर्निंग होती है, अनसुपरवाइज्ड लर्निंग होती है, reinforcement learning होती है. Right? Make sense? So slowly and slowly we'll talk about that. इनमें मैं ज्यादा टाइम नहीं लगाऊंगा, because these are the things you are going to learn in second year and third year, not now. Right? So these are few algorithms. Linear regression is there, logistic regression is there, graph method is there, Markov decision is there, a lot of things are there, nothing to worry about it. Only thing is, yes, you need to understand the concept what we are talking about at this moment of time during your first year. Second year and third year, we are going to implement those algorithms in our classes. So when you talk about computer science, definitely this is what you are going to learn. This is what you are going to implement, and this is what your curriculum is all aligned to. So when you talk about basic computer science, 4 blocks. First is programming, database management system, machine learning tools, and statistical tools. That is how you are going to build your complete toolkit of data science when it comes to computer science. Small block. So now we have understood a very broad information about all the four major blocks of data science. Let me now quickly throw you to a complete life cycle of a data science project. Then you'll be able to understand कैसे कैसे link हो रहा है ये सब कुछ. So first thing first, let us say you are going to work on a data science project, how you should start. So first thing first, define your goal, what you want to achieve. When you have defined your goal, you need to collect data, and then you need to manage data also. Then you need to build a model, find a pattern, lead to a solution. When you have built a model, then you need to evaluate it. When you have evaluated that model, you need to validate it and then present that particular result to your management, how you have solved that particular problem, and then deploy that model. This is how you are going to execute any given data science project. It is very, very important for us to understand that yes, I need to define my goal, I need to collect data, I need to manage my data, I need to build a model. Model means either supervised learning or unsupervised learning or reinforcement learning. And various algorithms are there. That is how you can correlate. Then when you are evaluating your model, how you will evaluate? You will define accuracy and precision. When you have evaluated your model, you need to document it and find the results. When results are acceptable, you deploy it in a given scenario. That is how any given data science project works. So let me very quickly run through a business model, business use case. Let us say there's a bank, and that particular bank is feeling that there are many bad loans which are adding to their losses. And a data scientist has been called to help the bank on this particular thing to reduce their losses from bad loans, say by X%. So when it happens, so now let us follow the 6 steps, what we have learned just now as far as any given data science project is concerned. So first thing first, I need to define my goal. That was the first step, right? So that particular goal should be measurable. That should be quantifiable. Two important terms you always need to consider while mentioning any goal. When you are defining any goal, the goal should be measurable, goal should be quantifiable. Now, when we talk about, okay, I need to reduce the bad loans by X%. Whenever I will be evaluated, I will be measured, they will say that, okay, bad loans in the initial of project was so much, now it is this, how much you have improved, that is my success parameter. That is how you need to define your goal. That is where you can say that, okay, I will reduce that particular thing by 10%. So that is how you will do your first step. Second, then you need to collect and manage the data. What type of data is with us? Will it help to solve the problem? Is data enough? Is data quality good enough? These are the questions I need to answer. So when you talk about bad loans, it is primarily giving me one particular span that yes, how many active loans may go for a bad loan and what are the parameters you need to define. So this is second point. Then definitely I need to build a model, whether it is classification model or it is clustering model, whether it is supervised learning, unsupervised learning, reinforcement learning. I need to take a call on this. So that is how I will progress in my project. Then just say I need to take a decision that this loan may go into bad loan category. It may be a decision tree. Various algorithms are there. You will learn those algorithms in due course in next 2-3 semesters. So you need not worry about it, what we are talking about here. But yes, try to understand that, yes, that is how you are going to build a model. Then I need to evaluate it. Accuracy. That's what we talked about. And when we talk about accuracy, okay, it is primarily telling me that, yes, these are the parameters helping me to achieve better accuracy or precision as compared to other models. Then I need to present the whole result to my management, and then I need to deploy it. That is how the whole data science project will move. Why I am telling you this particular thing? Because if you are planning to explore your career in data science, you need to follow these 6 steps. One by one, you need to master those steps. And when you are master of those 6 steps, I think you'll be a very successful data scientist in future. So you need to make sure, number one, a clear, verifiable and quantifiable goal, set the realistic expectation, unbiased data set covering, right model, and right deployment. That is how these factors will ensure success of your data science project. Very quick, top 10 use cases of data science. This is what industry is working at this moment of time. Churn prediction, sentiment analysis, online advertisement, recommendations, truth and veracity, news aggregation, scalability, content discovery, intelligent learning, personalized medicine. So these are 10 use cases I would request you to go through after the session. Just search what is churn prediction, what is sentiment analysis. It will give you a lot of use cases, a lot of videos on YouTube where they will tell you what is happening in these fields. Very, very important for us to understand. This is one question we need to answer. That's what we answered. We questioned during our AI session also. Can AI be the ultimate thing? Can data science solve all problems? Answer is no. There's no single approach altogether. But yes, technology and frameworks are helping me in making sure that there's a great potential for me to implement data science in various society related problems around me in the globe. Few challenges. So these are the use cases. So can I handle unemployment? Can I handle health and welfare? So these 4x4 matrix 16 points will give you 16 projects if you want to explore. That is how things move. So this is what is all about from my side. That's what the data science is all about. I hope it has given you a good perspective to start exploring the topic. It was just a beginning where we have touched upon the whole framework, whole technology, whole learning curve from a 30,000 feet height. Now, next step will be come to 20,000 feet, come to 10,000, come to 1,000, come to 100 feet, and start exploring those 6 blocks of data science. I'm open to questions if you do have any, and then we'll wind up the session. Use the chat window to put your questions across, and I would be able to handle. Good. सो तो नहीं गए सारे? जाग रहे हो ना? Good. Sahil puts a first question. It cannot solve all problem, but at some extent it can, like crime happening, data scientist promotes it. So even a state or country or any minister won't be able to cover up if they want? Answer is yes, you are right, absolutely. Yes, we'll share the recording of the session. You need not worry about it. When one could be a data scientist starting today? This is the answer to your question, Vicky. Starting today, you can be a data scientist, but yes, you need to understand those 6 steps. First, you need to define your goal. Then you need to gather the data, then work on veracity, work on model, evaluate that model, present it, visualize it, and then deploy it. Why machine learning is important for data science? Like as we are learning coding, computer understand it automatically. Answer is big yes, because whenever you are talking about implementing a science on a given data, let me repeat my line. When you are going to implement any science on a given data, you need certain frameworks, certain algorithms, and that particular set of tools is being provided by machine learning. Okay. Good. So another question from Sahil. Data science is so strong today. It happens to me when I was talking about price of Burj Khalifa, and after that I just searched what is the price, and it showed it out of nowhere. They even listens. Answer is yes. You are absolutely bang on, Sahil, because this is what it is happening. Let me give you one example in continuation with your question. I was just standing in Sector 26 Market, Chandigarh, and all of a sudden, I get a message from Pizza Hut. There's one-on-one free. It was not Wednesday or Friday. It was Tuesday. One-on-one free on your favorite cheese pizza, but only on this particular outlet. And that outlet was Sector 26. Just to let you know, I'm a pizza lover, and I regularly order pizza online. That is what they acknowledged, and then they signed up with my mobile company, understood that yes, I was standing in Sector 26 market, and immediately they floated me one offer which I could not resist, and I went for it. Today, all digital media are observing us, listening to what we are doing, and they know there's nothing like privacy, digital privacy altogether, Sai. This is my viewpoint. Any other question, friends? Anyways, perfect. So Alok sir will send the quiz right after this session, and I would request everybody to just open that, and if you have listened to what I have talked during last 70-80 minutes, you will be able to answer each and every question. But Google is always available. You can Google it out also. But yes, appear for that particular quiz. Okay. Thanks, friends. It was nice interacting with you. We'll be meeting with next technology in coming week. Hopefully, you will try to explore whatsoever we have discussed today, so that you make a basic outline in your mind where you would like to go for as far as your career progression is concerned. That will help you a lot. Wherever you feel like asking a question to me, please come down. I'll be more than happy to resolve your query. Thank you.